how important oxygen is. And so oxygen or like sensing on liquid marasin, Bigman and Olympista Saben Mogem and it is still going to be served in a gas form. So time you be sick, our oxygen percentage in the body drops down. That is called saturation. It's a clinical term, you don't need to worry. But for the interest of the environment, you have to know this part. So when your saturation level drops down, you want to put you so it is measured in SpO2. Saturated oxygen is measured in SpO2. That must be around, if you are normal, up in the high altitude is different, and the lower in the coastal places. So when you are here, it must be 90% and above. If you're in a coastal place, the good is about 90%, 95% and above. Up in the high altitude is 90%. But if clinically, if you are lower than 87%, then you are using hypoxia or can deal with gas. But you can come down as low as 60, 52. So when that happens, not on the marasin. So the marasin level but turning to is oxygen. So how do we get oxygen? We use the technologies that are available, and now we will be producing our own oxygen. That's how we go through this now. Okay. Okay, how we get that high purity oxygen out of the 21% that you will breathe in? How do we get that? So this machine helps us to do that. What it does is that normal air that you will breathe in, it passes through the compressor. This compressor. Okay, compressor, cheap air, it compresses and then passes through the line. And we have a filtering system here, first line of filter. When air is compressed, what does it happen? What does happen? When you compress things, it produces heat. When you compress things, it produces heat. That's what we were basically saying in the refrigeration now. Compressor come out long and it's got a high pressure and it's got heat. And so that's for the nation of British people. Actually, hello. What happens? The compressed gas, it heats up. The heat, O1, is a pass through. But when it compresses, the air, it creates moist. What I want to come. So that's when this filter is filtering two things. The dirty that is compressed through the compressor and also filtering the moist water that will come on there. And then it comes to this what it called dryer or refrigerant. What it does is it dries and cools off the hot air that is produced by compressor. So then for how long in? It's a cool, nice cloud. Air is a gone. What happens to here with what? Some filters here. In normal setup, you will see only one. The best I can put in two, but not the third one. But for here, I just decided to throw the third one in because we really needed to filter any unwanted contaminants, dust, that's why before the train once. So that's all. The fine filtration, any water. So in this line, most water is captured in this filter. The second thing, and kissing the air, this filter. Liquid maybe. When we open it, we might get it after maybe 1 year is in operation, you can say 1 year. This one, nil. But that's called micron filters. If you have worked with filters, you would know. Micron is a very minute filter step. So stuff for dust and collection. So that's how the filtration process in air. So the clean air, the very clean air, comes through the pipe, goes in here. That's what we call the air receiver tank. Air receiver tank. So, good na air long in, but go sit down long in. Air receiver tank. We've got two air receiver tanks. One, put the air long in, put the same. Okay, what it does is, inside those two tanks, nothing is in there. These two tanks are very unique tanks. These are two large. These two tanks, outside them, air receiver tank. Air comes down onto the green blood tank. These two tanks, they're called sieve tanks. S-I-E-V-E. Sieve tanks. So they are very special tanks. These two tanks. Half of this or quarter of this, depending on the manufacturers, also adding, they had a small particle called zeolite. Z-E-O-L-Y-T-E. Zeolite. Okay, one unique property of this particle, zeolite. What it does is it holds the nitrogen. And so only this nitrogen composition, nitrogen, oxygen, and other gases that we compare. And answer only other gases and nitrogen and Olympus. And then let go of the oxygen. So, and only Michelin stop, oxygen are come up. And then come through and fills that tank. That's oxygen product tank. That's oxygen product tank. So this tank, start one kind. So what it does is, this air coming and filling this tank here, it runs in a cycle. So that cycle is all dependent on the manufacturers. For this case, it's a 45-second cycle. So within that 45-second cycle, one plug on this tank and producing oxygen. And within that 45 seconds, another plug and rousing nitrogen and other gases on this opposite tank. So our aims are rousing, and whatever oxygen that is producing here, sometimes most of them go not taking half, but some long and using flushing down this nitrogen and other gases that this zeolite micrograms are attracting the whole stuff there, and are flushing that down. So that 45 seconds, after 45 seconds, M producing, this is removing, the next one, the change of it. The cycle changes, and that's how we get the product oxygen filled in this tank. 21, heading over here, that's how oxygen purity and so increase for 100% 99. So that's how we get the oxygen at a higher purity. Any questions?
Those two cylinders, they've got separators there, separation, but gases or something.
And when gases
separating all different gases, like oxygen or another plant, the one that doesn't require, and then
yes, okay. And the separation. Oxygen is produced in different processes. One is through the separation process, where it is called columns. That's one. We're not using that one here. This one, we're using one term, which I will come later. You can use another process called PSA, volume swing absorption system. We're not using that one here. This system is called PSA system. So it's pressure, swing, pressure, swing, absorption. ADSORPTION. Absorption. So that process you be using lots. So what I'm talking about and the thing was it's a columns process and separation there. That's a different. That's how liquid oxygen is captured through the columns separation process. But this one is PSA system, pressure swing absorption system. So that's why it's a geolite particle and start looking at volume. That's how it separates and then let go off. On control support, it's just a control. I'm talking about just whistles and whatever. But for maintenance purpose, yes, we can go in there. So you've got a gauges to read off the content of each, and then we've got a solenoid valves in there. It controls the process of producing the oxygen. So we've got 2 feed valves, which opens to feed the compressor air in. We've got 2 waste valves to remove the waste that is being produced, and we've got about 3 equalization valves. So what it does, it equalizes the process during the removal of the gas and then allowing the product oxygen to go and fill in there. So we've got about 7 solenoid valves. They are pneumatic controls. Some solenoids electronic, some mechanical. So these are pneumatic air control. When they get the signal like PC computer login password, opening valve kind of thing. So that's pneumatic control valves. This last time. Any question before I move on? Through this process, the oxygen purity that we achieve is 93% plus or minus 3%, meaning that the machine is capable of producing from 90% to 96%. However, the beauty that we had, because we did our own specification, I throw in this part, which is extra. This one we can go inside when I did the specs for this one. So this is another mini Visla, which is called purifier. So same operation, same all the particles we took care and start all this there. The beauty of this one, 96% are go along in here. And ends are come on this tank, and then coming out of this is 99. So from here we are capturing the extra 3%, and that's first in PNG. Even again, without Frank go along in here, M on 96%. They can come on 95. But for us, we've added this one. We proved it, people are running, we got 99%. So that's the beauty about us. So that's the extra that we've added. So from there, Enga come oxygen tank, and then from the oxygen tank, this is another compressor. This one is not an ordinary compressor like what we have on the other side. This is a unique compressor, what we call booster. It's a high pressure compressor. What it does is the product that is taken here and even go along and then we need a high pressure. The filling of these cylinders. Come to here, filling these cylinders. So this is the filling rack. We've got 8 on each side. And then we fill this one, excuse me. That's the oxygen we have. We played filling on here. So that's oxygen. So once come out, because of high pressure and the pump go inside, filling would come back straight finish now. Once it's full straight down, pressure differential, and then this compressor will automatically